Test if a variable is a list or tuple. In Python, what's the best way to test if a variable contains a list or a tuple, i.e. a collection? Is isInstance as evil as suggested here? This URL. Update. The most common reason I want to distinguish a list from a string is when I have some indefinitely deep nested tree/data structure of lists of strings, etc., which I'm exploring with a recursive algorithm, and I need to know when I've hit the leaf nodes.
There's nothing wrong with using isInstance as long as it's not redundant. If a variable should only be a list/tuple, then document the interface and just use it as such. Otherwise, a check is perfectly reasonable. This type of check does have some good use cases, such as with the standard string starts with / ends with methods, although to be accurate these are implemented in C and Python using an explicit check to see if it's a tuple. There's more than one way to solve this problem, as mentioned in the article you linked to. An explicit check is often better than trying to use the object as a container and handling the exception that can cause all sorts of problems with code being run partially or unnecessarily.
Go ahead and use isInstance if you need it. It is somewhat evil, as it excludes custom sequences, iterators, and other things that you might actually need. However, sometimes you need to behave differently if someone, for instance, passes a string. My preference there would be to explicitly check for STR or Unicode like so. NB don't mistake types.string type for types.string types. The latter incorporates STR and Unicode objects. The types module is considered by many to be obsolete in favor of just checking directly against the object's type, so if you'd rather not use the above, you can alternatively check explicitly against STR and Unicode, like this. Edit. Better still is end edit. After either of these, you can fall back to behaving as if you're getting a normal sequence, letting non-sequences raise appropriate exceptions. See, the thing that's evil about type checking is not that you might want to behave differently for a certain type of object, it's that you artificially restrict your function from doing the right thing with unexpected object types that would otherwise do the right thing. If you have a final fallback that is not type checked, you remove this restriction. It should be noted that too much type checking is a code smell that indicates that you might want to do some refactoring, but that doesn't necessarily mean you should avoid it from the get-go.
On Python 2.8 type list is list returns false. I would suggest comparing the type in this horrible way. Well, at least on my system, using Anaconda on Mac OS X Yosemite.
Some sort isn't the guidance